Welcome to The Explainer. Today we're exploring something absolutely fascinating. The $300 cooling tunnel that replaces air conditioners and the Amish technology behind it. So picture this. You're standing at the mouth of a tunnel that runs right underneath a traditional Amish farmhouse in Holmes County, Ohio. There are no wires, there's no noisy compressor buzzing outside, and absolutely zero thermostats on the wall. Yet, the air flowing out of this tunnel is a crisp 55 degrees in the dead of a sweltering August afternoon. It's wild, right? This whole anomaly is basically a $300 cooling system that relies on literally nothing but the dirt beneath your feet and a tiny fan that draws less power than a single light bulb. The Amish have been using this for 2 centuries, and ironically, the modern cooling industry has known about it and kind of swept it under the rug since 1930. Today, we're going to unpack exactly how this works, why you've probably never heard of it, and how you could actually replicate this the whole shebang right in your own backyard.
Okay, let's dive into this because the entire concept hinges on this one single fascinating number, 55 degrees Fahrenheit. Here is the physical rule that literally changes everything about how we look at cooling a home. At exactly 6 feet below the surface of the Earth, the ground temperature just locks in. It acts as this constant temperature vault all year round. Whether there's a massive blizzard raging up top or a 100-degree summer heat wave, the dirt 6 feet down simply doesn't care. It stays incredibly stable.
And this isn't just some educated guess we're throwing around. We're talking heavily documented data straight from the Department of Energy's Oak Ridge National Laboratory. They literally measured soil temperatures city by city. Check this out. In Chicago, the ground sits at a stable 55 degrees all year. Atlanta, 62 degrees. Denver is 58, Phoenix is 67, and up in Minneapolis, it's 52. And right there in Holmes County, Ohio, where those Amish farms are, the soil holds remarkably steady between 54 and 56 degrees every single day of the year. It proves that no matter where you live, the earth right beneath your feet is holding on to a remarkably stable, cool temperature.
Now, what's really interesting about this slide is the sheer scale of the efficiency gap we're looking at. So engineers measure cooling efficiency using something called a coefficient of performance, or COP. Your standard modern air conditioner, which, works by compressing chemical refrigerants and forcefully dumping heat outside, gives you about 3.5 units of cooling for every unit of electricity it uses. But an earth tube system? Across 47 monitored installations worldwide, it hit a staggering COP of 28.7. 28.7 versus 3.5. That massive gap, that represents billions of dollars in lost HVAC revenue. It's equipment, refrigerants, electricity, and service contracts that you suddenly just do not need.
To really understand why this works so flawlessly, we have to look at what the dirt is actually doing. Think of it as an earth battery. Soil is incredibly dense, weighing between 100 and 125 pounds per cubic foot. Because of all that mass, moving its temperature even 1 single degree requires a massive amount of energy, roughly 20 to 30 BTUs per cubic foot. So when the summer sun is absolutely baking your lawn, that heat starts sinking into the earth, but it moves incredibly slowly. It actually takes 6 to 8 weeks for surface heat to push just 6 feet down. By the time that summer heat finally arrives down there, the season above has already changed to autumn. The Earth simply cannot absorb the heat fast enough to warm up. That makes the ground beneath every single American home the planet's absolute largest, totally unused thermal battery.
Section 1. The Amish, Breath of the Floor.
Now, the Amish didn't figure this out by sitting around reading physics textbooks. They just paid close attention to the Earth and built their lives around it. Over 2 centuries, they refined this applied physics into a technique they beautifully call the breath of the floor. Basically, underground clay pipes cool the air rising right up through their floorboards. Let's look at how they did this. First, you've got root cellars dug 10 feet deep. No insulation, no mechanical cooling, yet the soil naturally keeps them between 32 and 40 degrees year-round. Then there are spring houses. These are small buildings built directly over natural springs where groundwater flows at a constant 54 to 56 degrees. It keeps the whole interior between 50 and 58 degrees all summer long without a single watt of electricity. And hey, this wasn't some highly guarded secret. The USDA actually published a manual way back in 1903 specifically documenting these Holmes County clay pipe setups. That was over 120 years ago, and those exact systems are still running perfectly under Amish homes right now.
Section 2.
The $29 billion HVAC cover-up. So this naturally begs a huge question, right? If this technology is so incredibly effective, was documented over a century ago, and costs basically nothing to run, why don't we all have this in our houses today? Well, to answer that, we got to look at the history of the modern HVAC industry. It all starts in 1902 when a guy named Willis Carrier invents mechanical air conditioning. But here's the kicker. It wasn't for human comfort. It was just to control humidity in a Brooklyn printing plant. Fast forward to the 1920s, and his company launches this massive weather maker marketing campaign. They totally repositioned AC as the ultimate symbol of American progress, while simultaneously painting natural passive cooling as primitive. By 1927, the very first building codes were being drafted, and, surprise, surprise, they were heavily influenced by HVAC industry reps. By 1980, the shift was totally complete. Fewer than 3% of American architecture programs even taught passive cooling strategies anymore. And this brilliantly illustrates exactly how an entire field of knowledge can just vanish. I'm going to read you a direct quote from a 1930 Carrier Engineering Corporation manual. It literally says, "Earth contact cooling is suitable only for cellars and food storage." Boom. With just one single sentence in a corporate manual, 5,000 years of proven passive engineering was effectively buried. It wasn't explicitly banned, it just completely ceased to exist in the rule books.
But why? Well, you know what they say, follow the money. And the motive here is pretty obvious, $15,000. That right there is the average lifetime value of a single residential HVAC customer in America today. The residential cooling market is a $29 billion a year industry. Every permanent $300 earth tube installed is an air conditioner that never gets sold, a compressor that never needs replacing, and a very lucrative service contract that never gets signed. And we can still see this dynamic playing out in today's regulatory environment. Just recently in 2019, an ASHRAE technical committee rejected a proposal to create a performance pathway for earth tubes. The reason? Insufficient domestic performance data. But it's definitely worth noting that 67% of the people on that committee were representatives of HVAC manufacturers. In 2021, the Building Officials Association of Florida formally opposed an amendment recognizing passive cooling, claiming it made inspections too complex. And if you look at the lobbying money, the Air Conditioning, Heating, and Refrigeration Institute spent $47.3 million on political lobbying in 2022 alone.
Section 3. Global Proof of Concept. Let's move to unsee how this builds across the world. Because while America largely abandoned this passive technology, the rest of the world took it and refined it into massive, modern infrastructure. Check out these huge commercial applications. The Cambridge Public Library in Massachusetts uses 42 buried earth tubes, cutting their total energy use by over 50%. The Earth Ranger Center up in Toronto uses 9 massive 65-foot concrete tubes that literally cool the incoming summer air by 18 degrees. And get this, a hospital in Vienna has been cooling its critical care units using earth tubes continuously since 1994. So yeah, these aren't just little backyard science experiments. This is the Earth being used as proven, large-scale infrastructure.
And the data coming out of Europe is even more robust. Germany currently has 847 heavily monitored residential installations that they've been tracking since 2005. Over in Austria, they actually require thermal labyrinth analysis for any large new building. And in Switzerland, a 15-year study by ETH Zurich, which is one of the top engineering schools on the planet, showed zero system degradation over a decade and a half. So the exact same knowledge the Amish brought over from Germany and Switzerland 200 years ago is now heavily monitored, totally mainstream engineering in Europe today.
Section 4. Building a $300 cooling tunnel.
Now, you might be wondering, does this only apply if I'm building a massive hospital or a brand new house? Nope. You literally only need a narrow strip of land to make this work for an existing home. Here are the actual steps. First, you dig a trench 6 feet deep and about 100 to 200 feet long. Second, you lay down smooth-walled HDPE or PVC pipe on a bed of sand. The sand gives a maximum thermal contact, and the smooth wall is absolutely mandatory. Corrugated pipe can trap moisture and get moldy, so avoid that. Third, you slope that pipe at a 2% grade so any condensation just drains right out. Fourth,
Connect one end to an above-ground screen intake. And finally, the pipe enters your home, maybe through a basement wall or crawl space, where you attach a standard MERV 13 air filter and a small 50 to 80 watt inline fan. That fan draws roughly the same power as one single light bulb.
And the outcome of this incredibly simple setup is honestly amazing. For about $300 in basic materials, on a blazing 95-degree summer day, the air traveling through that cool earth exits into your living room between 65 and 75 degrees. Plus, because condensation naturally forms on those cool underground pipe walls as the hot air passes through, it physically pulls moisture right out of the air, dropping the humidity from a muggy 80% down to under 50%. You are getting fresh, cool, dry air, driven 100% by physics through pipes that'll easily last you 50 to 100 years.
But hold on. If you live in a really wet environment, you're probably asking the obvious question. What about high humidity climates? How does a buried pipe handle the intense, heavy condensation you'd get in places like coastal Florida or the deep south? It's a completely valid concern because, yeah, pulling hot, swampy air through a cold underground tube can definitely turn into a moisture management nightmare.
Section 5. The humidity-proof glycol loop. So, the crucial point is, to solve that humidity issue, there is a brilliant zero-permit workaround designed specifically for high humidity areas. Instead of pulling outside air through the pipe, you bury a closed loop of liquid. It's just a mix of water and glycol, the exact same antifreeze you put in your car. This liquid circulates through the buried loop, absorbs that constant 55-degree earth temperature, and then passes through a heat exchanger inside your house. Because outside air never physically touches the buried pipe, there is zero risk of condensation, mold, or radon creeping into the underground lines. And even better, because it uses liquid and standard pipes, the city just classifies it as standard plumbing. It completely bypasses all those restrictive HVAC codes that don't even know how to classify earth contact air systems.
Check out this amazing real-world example. There's a homeowner down in rural Tennessee who built this exact closed loop under his 1970s workshop. He built the whole thing for just $400 in materials, digging the trench himself over a couple of weekends. He hooked it up to a simple $80 fan coil unit and a tiny 40-watt circulator pump. The result? His $240 a month heating and cooling bills dropped to absolutely zero. In the summer, the fluid dumps the house's heat into the cool earth, and in the winter, it pulls that 55-degree warmth from the earth right into the house. It's two for the price of one. And the absolute best part? His old furnace and AC are still sitting right there. The whole system is fully reversible in about 5 minutes if he ever decided he wanted to switch back.
And taking a step back, we realize that none of this is actually new. We are looking at 2,400 years of earth cooling history. The ancient Persians built ice houses to survive 120-degree desert summers. The Romans engineered cooling channels right under their villas. The Koreans ran air passages under their floors for 3,000 years. Native Americans built semi-subterranean homes for millennia. Literally every single ancient civilization that had to survive extreme climates independently arrived at the exact same physical solution. The earth stores the temperature, the pipe is just the path. The Amish kept this knowledge alive simply because it worked, and they didn't need anyone's permission to use it. Now the rest of the modern world has proven it works at scale. The physics are absolutely undeniable, and all the materials you need are literally sitting right now at your local hardware store. Which leaves us with one final, very important question for you to consider today. What is the dirt beneath your house doing right now for free? Thanks for joining me on this explainer. Keep questioning, keep learning, and I'll see you next time.